This is part A, experimental diffraction quantitative. So we have a laser diode at 650 nanometers that goes to our diffraction grading, and then we have a lens system to condense the optical system in a camera, which shows our pattern on the computer. So we had 4 single slits, the 20 micrometer, which we calculated a Fraunhofer region of 15 centimeters, the 40 micrometer, which we calculated a Fraunhofer region of 61 centimeters, the 80 micrometer, which we had a Fraunhofer of 246 centimeters, and the 160 micrometer, which we calculated the Fraunhofer region at 985 centimeters. For the 160 micrometer slit, we see the sync function going in and out of our Fraunhofer region, and as you move it back towards the camera, it changes to the size of the slit and it gets vertical, and you see a lot more interference patterns.
Since the Fraunhofer diffraction is the Fourier transform of the aperture, if we have a vertical slit, the Fourier transform will stretch it in the horizontal direction and make it short in the vertical. Then we looked at the double slits, and we have a 40 micrometer slit separated by 250 micrometers, and we have the 80 micrometer slit separated by 500 micrometers, and these were different to the single slits. We can observe fringes in the Fraunhofer region from the double slits.
So for our square aperture, we see the pattern radiating out from every face. For the circular aperture, we have kind of Haydinger fringes, or a form of Haydinger fringes, and then for the triangular aperture, we have these hyperbolic fringes coming out. For part B, we used a rectangular aperture that was 200 microns by 400 microns, and we took that image and we put it in a MATLAB code to get its intensity of the pixels in the X and Y direction. So first, for the X direction, we found that the first peak had a value of 0.454, and in the Y direction, the first peak had a value of 0.04609, which respectively had a percent error of 0.9% and 2.4%. And then for our second peak, intensity peak of I over I naught, for the X direction, we found 0.1383 and 0.01383 as well. So these both had a 13.56% error. And then when we found the distance between the minima and the peak up here, we found that the peak was offset by 1.7% error.
For part C, we replaced the rectangular slit with a 500 micron diameter circular aperture slit. We captured the image of the Fraunhofer diffraction pattern and used the MATLAB code. For the first I over I naught maximum, we found in the Y direction the value of 0.01778, and for the X direction a value of 0.01778, and got a percent error of 1.6% from the value of 0.0175. For the second peak, we got a value of 0.00444 in the Y and X direction, and got a percent error of 5.7% from the value of 0.0042. We found that the first peak was 27.8% offset from the center, which means that the sombrero function isn't fully symmetrical.